Hi, in this lecture we're going to be talking about simulating projectile motion in Scratch, and this is the video where we're going to put together the laws that we've learned, Newton's laws of motion, with the basic coding skills that we've learned in Scratch to actually create a simulation that uses those physical principles to try and predict how far an object will go when launched at a certain velocity and angle. So here we are in the video series. We're on video 5, simulating projectile motion using computer code, part 1. If you need to catch up, feel free to go back to those previous videos and you can find the links to those in the comments below. One thing that I want to visit before we get into the computer code is this idea of a free body diagram. Remember from previous lectures, free body diagram is basically this idea of trying to identify all the forces that might be acting on an object. So rather than a man falling from the sky that we've used previously, here we're going to use a ball or a projectile that has been launched. And let's say that that projectile has been launched and it's traveling basically from left to right. The point I want to make here is that forces can act in different directions on an object. So in this case, we're going to have gravity acting downward. And since our velocity is going toward the right, the drag force is going to act in the opposite direction toward the left. So when we get into our computer code, we're going to break down some of our key variables: position, velocity, and acceleration, and as well as the different forces. We're going to break those down into each of those variables in the x direction, which we're going to consider to be basically horizontal, and also in the y direction, which we're going to be considering to be vertical. So in our case, we're going to treat the y direction, if y is positive, or if you have a positive y velocity, that means the object is going up. If it's negative, it means it's going down. Okay, so with that behind us, we're going to go get into Scratch, and we're going to actually start over with some new code here. So launch your web browser. This works best in Google Chrome, and I recommend watching this not on a phone, but rather on a computer screen, because you're going to need to see quite a bit, and the fonts might be a little bit small. So I'm going to go ahead and launch Chrome and go to scratch.mit.edu. I'm already logged into my account. If you're not, you'll need to just sign into your account and use your username and password. I'm going to go to Create. And the first thing I'm going to do, this is always a good coding practice, is create a file name and actually save this file. So I'm going to call this projectile motion, and then I can go here, File, Save Now. I haven't really done anything yet, but I want to be able to save frequently so I can come back to this later if I need to. Eventually we're going to be launching projectiles and not this little cat, so I'm going to delete that little cat here, and I'm just going to go to choose a new sprite, which basically means a new object or a new character. I'm going to choose this little ball. I can go down here to size, and I can shrink this down a little bit, so I'm going to go from 100 down to 40. Alright, so there we go. There is our projectile, or our little object that we're going to be launching. Okay, so we're going to go to events. We're going to want to have some event that will trigger our code to start. You can do a certain key being clicked or something. I'm just going to use this little green flag. It doesn't particularly matter all that much. Okay, so if you remember, when I move, I want you to look here. This is our X position, which is built into Scratch. This is our Y position. So just like when you're doing X and Y graphs, if I move this guy around, you can see those coordinates change. So down here in this lower left quadrant, I have X is negative and Y is negative. Up here in the upper right, I have they are both positive. So we're going to be launching this projectile going from left to right. We're going to add in gravity, so we should see our projectile basically doing something like this over time. So what I want to do is I want to launch this thing from a consistent place each time. So when I start my code, I'm going to tell it to go to a specific coordinate. And so I'm going to go, I want it to start out at minus 220 in the X direction, which means basically on the left-hand side, and Y at 20. And when I go here, that'll automatically move my little object back to that spot. So if I grabbed my mouse and moved it away somewhere, as soon as I click, I can click the flag here, that'll move it back. Or I can click the flag here, that'll also move it back. Okay, so pretty basic. Every time we start our code, this is called initializing your code. You're basically telling, okay, I want to start with these particular variables, the x position and the y position being these set values, so that every time we run our code, it'll go to this same position. We also want to define, so x position and y position are variables that are like built into Scratch. We want to define some new variables, so I'm going to go down to this little variables block down here. I'm going to create some new variables, so I want to create x velocity. So that creates this new variable x velocity, which will show up in this little workspace here. I also want to have a y velocity, because remember we're going to break those up into two separate directions. What also happens here is that when x velocity and y velocity are checked, that displays them here, and we could uncheck them, and that will take them away from the display. So for now, let's just leave them there, it's fine. I want to create other variables. I want to create x acceleration, and I'm giving these shorter names just to make the code a little bit shorter, and then I'm going to do y acceleration. So what I want to do at the beginning is I want to initialize these variables as well, so I want to give them set values. The scenario that we're going to run starting off is we're going to assume that we have some kind of launcher here, and it's going to be launching our projectile in the x direction, and then eventually gravity will be working on it and will give our object a y velocity. But basically, we want to give it an x velocity. So when I'm initializing my code, I want to go here and define my x velocity. And for now, I'm going to give this a velocity of 70. This would be 70 meters per second. We're going to try and stick closely to meters as our basic unit of distance and seconds as our basic unit of time. And those units are actually quite important. So I also want to go set my y velocity. But in this particular scenario, I'm not going to launch the ball upward or downward at all. I'm just going to launch it straight horizontal. So I'm just going to give it a y velocity of 0. I mentioned in a previous video that one of the tricks with getting these simulations just right is that things change with time. So we had that formula, velocity equals, we had the formula, our new position equals our old position plus our velocity multiplied by some kind of time step. So we're going to define another variable called time step. So I got this variable here. I'm going to also initialize that, and basically this is saying what's my interval at which I want to be simulating. So I'm going to go with 0.1 seconds, and that basically means every time my code loops around, it's going to move forward 0.1 seconds in time. And once we get this going, this will become more clear to you what these variables mean and what they're doing. Some other variables that we want to define are g, which is the gravitational constant. And to make this a little bit more convenient, I am going to set g, I'm going to give it a negative sign, because we're going to choose y upward is positive and y downward is negative. So gravity is acting downward, so we're going to just give this a negative sign to make our life a little bit easier. And remember that value was 9.81 meters per second per second. Okay, we're stepping through this. We also want to be able to have drag forces being able to act on our object here. So I'm going to create another variable. This is going to be a drag coefficient, and this is something that we won't get too much into this, but basically an object that is more aerodynamic will have a smaller drag coefficient. And then we also talked about, in a previous video, we gave that example of hanging your hand out the window when you're driving. If you're driving 5 miles an hour, you don't really feel much. If you're driving 70 miles an hour, you're going to feel a pretty significant drag force on your hand. And that's because drag force is proportional to the velocity that you're going. It's actually proportional to the velocity squared. So we would take that 70 miles per hour and square it, which would be a really large number compared to 5 miles per hour and squared. So we're going to have this drag coefficient, which is just a variable that's going to go in front of that velocity squared term. And so for now, I'm going to initialize drag. We're going to keep it at 0 for now, which means when we start out that we won't be including drag forces into our simulation. So I don't particularly care when we're talking about the display here. The time step is not something that's going to change. So I don't really care that we need to look at it all the time. Same with G and same with drag. So we can just clean up our little workspace over here and just look at the variables that are most important to us. Okay, so we're going to launch this ball toward going horizontal from left to right with some kind of an initial velocity. That velocity for now is going to be 70 meters per second. So what I want to happen is I want to take these little time steps of 0.1 seconds, and at each time step I want to calculate a new acceleration term and a new velocity term and then a new position term. And then I'm going to keep stepping forward in time every 1/10 of a second, and I want to be recalculating those variables each time. So in computer coding language, we're going to need what's called a loop here. And what I'm going to do is I'm going to get this repeat until something. And basically, we're going to launch this ball, and we want to see how far it goes before it hits the ground. So I'm going to have this repeat until our ball hits the ground. We need to translate that into computer language. So I'm going to choose some kind of y distance down here, some kind of y position. I'm going to go with about -150 to represent the ground. So I want this loop to repeat until y is less than -150. So I'm going to go to the operators section. I'm going to grab this less than operator. And here I'm going to go -150. In that box, you can just manually type in a number. But you see where there's this empty oval, you can also put a variable in that box. So I'm going to go actually to motion, because this is one of the built-in variables. And I'm going to come down here and find this y position. And these actually may be ones that I want to click so I can see what my x and my y position are as the simulation progresses. All right, so back to our little repeat loop. I want to repeat the simulation until our ball, until its y position gets less than 150, which essentially means that's when it hits the ground. Okay, so inside this loop, I want to be calculating acceleration first. Then I'm going to calculate the velocity. Then I'm going to calculate the position. Then we're going to repeat this loop, and it's going to keep recalculating those things over and over until our ball hits the ground. Okay, so how do we do that? So we're going to introduce some equations now. So when I go to my variables, you can have these little commands that will change the values of your variables. So I'm going to use this set command to set our acceleration terms. So here, I'm going to click this drop down. Here I want to set, I'll start with the x acceleration. So I want to set my x acceleration. It's going to be, I'm going to go to my operators tab. The operators tab is basically where you do mathematical operations. And I'm cheating because I've already written this code, but I'm trying to walk you through it. I'm going to use this something minus something else block here. So the first component of our acceleration, so we're going to think back to the forces that are acting on this ball. And those forces, if you remember, force equals m times a. So where a is the acceleration, we're basically going to forget about representing the mass in there, but we're going to be thinking about what would be causing this ball to accelerate in one direction or another. So in the x direction, we don't have gravity, so I'm going to put 0 here because there's no gravity acting on the ball in the x direction. That's only acting in the y direction. But we do have a drag force acting in the x direction. So as the ball is zooming along in the x direction, the drag force is going backward in the opposite direction. So that's why I've chosen this minus sign. So basically our drag term is going to be our drag coefficient multiplied by the x velocity squared. And I don't know of a good way to square things in Scratch, So what we're going to do is we're just going to use these multiply signs, and I want to multiply eventually these 3 different variables together. So bear with me here. I'm going to go back to my variables. I'm going to get this drag term, plug it in. So you want to be careful that the right box is highlighted in white before you drop it in there. So I'm going to get my drag term, and then I'm going to get my x velocity, and really I want to square my x velocity. Okay, this is all coming very fast. The reason I'm making a video is so you can go back and watch this and take time to digest it. So here, my x acceleration is going to be equal to 0. That's kind of a placeholder for gravity, but there's no gravity in the x direction. It's only acting in the y direction, which is either up or downward. In this case, it's acting downward. So the reason I have this minus here is that my drag force is going against the velocity term. So so if my ball is going this way, then the drag force is counteracting that velocity, and it's acting against it. Okay, so what I'm going to do here is cheat a little bit. I'm going to right click on this block and duplicate it, because I want to set my y acceleration term in that same block. And my code, for some reason, got activated, which is why it's highlighted in yellow, but it's not quite ready, so I'm going to hit stop to get rid of that. Okay, my y acceleration term does have gravity, so we want to include this force acting downward. And the drag in the y direction does not depend on the x velocity. Instead, it depends on the y velocity. So I'm going to switch out those x velocity terms. All right, so basically our code, we're going to step through. It's going to calculate, starting at time 0, it's going to calculate the x acceleration and then the y acceleration. Now the next step is we want to define the x velocity and the y velocity. So we're going to do that here. So I copied and cheated because this takes on a kind of a similar form. So here I'm going to set the x velocity and actually I'm going to get rid of those. I'm going to do this differently. Rather than use the set command, I'm going to do the change command. My apologies there. So here, once I know the x acceleration, now I'm going to calculate the x velocity, and that's going to be based on the... actually, I'm going to calculate the change in x velocity using another operator here. So if you remember, our update formula is that the new x velocity is equal to the old x velocity plus the x acceleration times our time step. So what I'm doing here is it's going to take our old x velocity and it's going to change it by this value, which is our x acceleration and our time step. Okay, so similarly, if I right-click this block, I can duplicate it, and I can change this from x velocity to y velocity. I need to switch out this x acceleration term to a y acceleration term. Okay, there we go. So next is going to be our positions. So the positions are a little bit different because, again, those are built-in variables that we don't have to create. So we can find a similar change command under this little motion block. So here, I want to be changing my x by some amount, and I'm going to go back to operators. I'm going to be, so remember the change in our x position is just our x velocity multiplied by our time step. So I go back to variables, and I get my x velocity multiplied by my time step. I'm going to do a similar thing for y. So here I'm going to change y, and I'm going to put in that multiplication operator. So this is my y velocity multiplied by my time step. Okay, so now what our code will do, it's going to start at this particular position and with these particular velocities, and it's going to, so with an x velocity positive, it means our ball is going to go toward the right. But then it's going to enter this loop, and in this loop it's going to calculate, okay, what's my x acceleration, what's my y acceleration. Once it has calculated those, it's going to use those variables in our next calculation of the velocities. Once it has calculated the velocities, it's going to use those velocities to calculate our position. Then it's going to hit the bottom of this loop, and it's got this repeat thing, and it's going to keep repeating, and we'll see our ball be moving across the screen. I'm going to go into full screen mode here, and I'm going to hit the go button, and there you see our ball floating across the screen. So it's been launched, and now it is going a certain distance. To make this a little bit more visual, another tool that we can add, if I go down here, I can get this pen tool, and this pen will basically help us track how our ball is doing, so we can compare one launch to another launch, for example. So at the beginning of my code, I can just do this pen down command, and then at the end of my code, I would do this pen up command, and then each time you launch it, you can actually do something like change the color. So I would go here to change the pen color, and then we don't want to make our screen too messy, so I'm going to give myself this erase block, which I could just click on later if I wanted to. So let's go back here, launch my ball. Oh, and it did did this funky pen up thing. So, so that's the trajectory that my ball took. I will erase it. Let's try that again. Okay, I think I need to move my pen up command. Let's see. I'm going to move my pen up command to be... Actually, no, sorry. What I'm going to do is I want to get rid of this little line in between. So I'm going to keep my pen up command down here, and I'm going to move my pen down command to be... Shoot. And my code is kind of going without me here. I'm going to put my pen down command here between those blocks. And I think change pen color doesn't really matter. All right, so when I click on this erase all, that'll get rid of all my previous code. Let's try this again. Okay, so we did a little bit of debugging there, which is an important computer programming skill. So we see we started our ball here at this x position of minus 220. We ended up with this x position of 193. So basically, using the units, we've got our ball went 193 plus 220 meters, so over 400 meters in this particular case with this kind of high velocity. Okay, so that is writing computer code. So let's take a look at what if we added, or what if we changed our velocity here. So I'm going to slow the ball down and just do it at 60. Let's see how that looks. So we've changed our pen color, and you can see if we launched it at 60, it goes this shorter distance. If we launched it at 50 and did the same thing, we've got this changing pen color to help us keep track. That's kind of interesting. So you can kind of do this, and you can collect a bunch of data this way from your simulation model and see how your prediction changes. Okay, one other thing I want to revisit before we end this video. I'm going to erase all of mine, all of my lines. So if you remember, we set this drag coefficient to 0, which basically means even though this is built into our x acceleration line of code, it's actually not doing anything because that drag value is just 0. So we want to give this a little bit of drag. First, let's launch one again at 70 meters per second. I'm going to go here. I'm going to launch it at 70 meters per second. Great. That's where we went. So now I'm going to give it a little bit of drag, and this number is a small number. I'm going to give it 0.002. I don't actually know what it is. This is something that you could do some trial and error and figure out what drag coefficient gives you the best results. So later on, when you're trying to compare your model to experiments, this is a variable that you can change to see what value of the drag coefficient gives you the best results. So we're going to compare a ball being launched at 70 meters per second with no drag to one that is now launched at 70 meters per second with a little bit of drag. So there we go. So the drag slows the ball down quite a bit because, again, as the ball's going, it has that wind speed, and that wind speed is pushing back on the ball, causing it to not go quite as far. Okay, I think I'm going to end there with a quick reminder to go to File and go to Save Now. So your code is saved. Before you close Scratch, make sure you're always saving it so that you can come back up. You'd come up here to your account, you'd go to My Stuff later on, and you can go to pull up that particular file that you saved, and you can go to See Inside to get back into your code and start working on it again. Anyway, that was kind of a long video, but I think this is really cool, fun stuff to show you how you can use physics, and specifically Newton's laws of motion, coupled with computer code to generate these really cool simulations to try and figure out how far something is going to go. It could be a ball, it could be a missile, it could be an airplane, it could be a car. You just got to make sure that you're getting the physics right so that your simulation is a good representation of what's happening in real life.